A British thermal unit, or BTU, is a unit of energy. A watt is a unit of power. Because they measure different things, energy and power, you cannot directly convert one to the other. It's like asking how many miles are in an hour. Miles are a unit of distance, and hours are a unit of time. You need a rate, like miles per hour, to relate distance and time. Similarly, you need to understand the relationship between energy and power to relate BTU and watts. Energy is the capacity to do work. It represents the total amount of work that can be done. Power, on the other hand, is the rate at which energy is used or transferred. It represents how quickly work is being done. The relationship between energy and power is described by the following equation: power equals energy divided by time, or energy equals power multiplied by time. In the International System of Units, or C, energy is measured in joules, and power is measured in watts. 1 watt is equal to 1 joule per second. In the Imperial System, energy is often measured in British thermal units, or BTU. 1 BTU is the amount of energy required to raise the temperature of 1 pound of water by 1 degree Fahrenheit. To relate BTU and watts, you need to consider the time element. For example, you can talk about BTU per hour, which is a measure of power. 1 watt is approximately equal to 3.41214 British thermal units per hour. Conversely, 1 BTU per hour is approximately equal to 0.293,071 watts. Let's look at some examples to illustrate this relationship. A typical window air conditioner might have a cooling capacity of 5,000 British thermal units per hour. This means that it can remove 5,000 British thermal units of heat from a room in 1 hour. To express this in watts, we multiply 5,000 British thermal units per hour by 0.293,071 watts per British thermal unit per hour, which gives us approximately 1465 watts. This is the amount of electrical power the air conditioner consumes. A heater might have a heating capacity of 10,000 British thermal units per hour. This means that it can add 10,000 British thermal units of heat to a room in 1 hour. To express this in watts, we multiply 10,000 British thermal units per hour by 0.293,071 watts per British thermal unit per hour, which gives us approximately 2931 watts. This is the amount of electrical power the heater consumes. Another way to think about it is in terms of energy consumption over a period of time. Suppose you have a 100-watt light bulb. If you leave it on for 1 hour, it will consume 100 watt-hours of energy. To convert this to British thermal units, we first need to convert watt-hours to joules. 1 watt-hour is equal to 3,600 joules. So, 100 watt-hours is equal to 360,000 joules. Then, we convert joules to British thermal units. 1 British thermal unit is approximately equal to 1055 joules. So, 360,000 joules is approximately equal to 341 British thermal units. Therefore, a 100-watt light bulb left on for 1 hour consumes approximately 341 British thermal units of energy. In summary, British thermal units measure energy, while watts measure power. To relate them, you need to consider the time element. 1 watt is approximately equal to 3.41214 British thermal units per hour, and 1 British thermal unit per hour is approximately equal to 0.293,071 watts. Understanding the difference between energy and power, and how they are related, is crucial in many applications, from designing energy-efficient buildings to understanding the energy consumption of household appliances. These concepts are also fundamental in fields like thermodynamics, electrical engineering, and mechanical engineering. Let's delve deeper into the concepts of energy and power to further clarify their differences and relationship. Energy, as mentioned earlier, is the capacity to do work. It can exist in various forms such as potential energy, kinetic energy, thermal energy, electrical energy, chemical energy, and nuclear energy. Potential energy is the energy stored in an object due to its position or condition. For example, a book held above the ground has potential energy due to its height. Kinetic energy is the energy of motion. For example, a moving car has kinetic energy. Thermal energy is the energy associated with the temperature of an object. It is the energy of the random motion of atoms and molecules within the object. Electrical energy is the energy associated with the flow of electric charge. It is the energy that powers our homes and businesses. Chemical energy is the energy stored in the chemical bonds of molecules. It is the energy released when chemical reactions occur, such as burning fuel. Nuclear energy is the energy stored in the nucleus of an atom. It is the energy released when nuclear reactions occur, such as in nuclear power plants. Power, on the other hand, is the rate at which energy is transferred or converted from one form to another. It is a measure of how quickly energy is being used or produced. Common units of power include watts, horsepower, and British thermal units per hour. 1 horsepower is approximately equal to 746 watts. It is a unit commonly used to describe the power of engines and motors. British thermal units per hour, as discussed earlier, is a unit of power commonly used to measure the heating or cooling capacity of HVAC systems. To further illustrate the difference between energy and power, consider the example of a battery. A battery stores a certain amount of energy, which is measured in watt-hours or kilowatt-hours. This energy represents the total amount of electrical work that the battery can do. The power that the battery can deliver is measured in watts or kilowatts. This power represents the rate at which the battery can supply electrical energy. A battery with a high energy capacity can power a device for a long time, while a battery with a high power capacity can deliver a large amount of current quickly. Another example is a gasoline engine. Gasoline contains chemical energy, which is released when the gasoline is burned. This chemical energy is converted into mechanical energy, which is used to power the engine. The power of the engine is measured in horsepower or watts. It represents the rate at which the engine can convert chemical energy into mechanical energy. Understanding the relationship between energy and power is essential for designing and analyzing various systems and devices. For example, when designing an electrical circuit, it is important to consider both the energy consumption and the power requirements of the components. The energy consumption determines how long the circuit can operate on a given battery, while the power requirements determine the size of the power supply needed to operate the circuit. Similarly, when designing a heating or cooling system, it is important to consider both the energy efficiency and the heating or cooling capacity of the system. The energy efficiency determines how much energy the system consumes to provide a certain amount of heating or cooling, while the heating or cooling capacity determines how quickly the system can heat or cool a space. In conclusion, while British thermal units and watts both relate to energy, they measure different aspects. British thermal units measure energy, while watts measure power, which is the rate at which energy is used or transferred. To convert between British thermal units and watts, you need to consider the time element, typically expressed as British thermal units per hour or watt-hours.